Welcome to the Diamond Element series by Mastel. In this series, we hope to assist our clients in making more informed scalpel purchases. We aim to promote the understanding of blade design in relation to wound architecture and to encourage customers to purchase lances in place of spears. This presentation covers Element 2, alpha angles. Today we will locate and define an alpha angle on the diamond scalpel. We will then define what constitutes a sharp or blunt alpha angle. And finally, we will demonstrate how the alpha angles should vary based on location on the diamond scalpel and intended use. An alpha angle is the included angle between two facet planes. As such, all edges on a diamond blade have alpha angles. A cutting angle is defined as an angle that is less than 110 degrees. There are two major types of alpha angles: non-cutting or blunt, and cutting angles. Every blade's cutting ability is directly related to its cutting edge alpha angles. To compare the efficiency of different cutting edge angles, we will use the same vector mathematics from Element 1. Most industries use 45-degree alpha angles as cutting edges. Therefore, we will be using 45 degrees as our standard cutting edge angle. Now we will compare the 45-degree edge to 35 and 30-degree edges. The 35-degree edge is 25% sharper than the 45, and the 30-degree edge is 46% sharper than the 45. Moving backwards, you can see that the 90-degree spear is 61% less sharp than the 45. From this, we can conclude that 90-degree angles are less efficient and require more force into the eye, which can cause stress to the corneal structure. As expressed in Element 1, a 90-degree tip angle, though technically a cutting angle, requires twice as much force as a 60-degree lance in order to pierce. For cutting, tip angles of 90 degrees are dull when compared with the industry standard 45-degree edge. Just imagine slicing a tomato with a chisel. Similarly, 90-degree angles are not appropriate for blade margins. For the blade margins, 90-degree angles are actually considered sharp. 90-degree edges at the wound margins create box-shaped incisions that can be detrimental to wound closure. When alpha angles are correctly applied to blade geometry, any cutting edges will be sharp angles between 30 and 45 degrees. The blade margins will come in two main forms: blunt edges for dedicated width blades, or sharp edges that feature cutting edges along the margins. The key here is to position cutting edges only in places where they are desired. In this presentation, we defined the alpha angle, which is the included angle between two facet planes, and we've shown how to differentiate sharp and blunt alpha angles. We compared sharpness levels of different cutting alpha angles between 30 degrees and 90 degrees. Doing so, we proved that smaller angles produce sharper edges. Finally, we discussed how strategic placement of alpha angles will increase blade efficiency and safety. This concludes Diamond Elements 2. In Diamond Elements 3, we will discuss dedicated width blade margin optimization.